consequence, right? So if you go through this branch, you might go faster. If you go through this other branch, you might actually not even get to the top of it. You might just fall off and all that stuff, right? So each route you take within that tree can lead you to a very different outcome. And that makes a whole lot of sense in the kind of like this that we're trying to model here. And I'll show you how. All right. So if we go forward, now look at this. All right. This is a classic example of what we like refer to as a decision tree. All right. So look at this. So this is a store, right? Apparel's chatbot. I'm sorry, apparels, right? And then there is a chatbot owned by this store that like this is very fictional. Now, a simple flow representation of the basic chatbot to help buy clothes, right? Because this is what you want your designs to look like at the end of them. That's why I talked about draw.io. I don't know if any of you have checked it out. So, but if you've not, after this slide, you could just like check it out on your laptop or Figma. If you're a very good designer, I mean I could do all this too with Figma, but you want to like be able to have something as explicit as this, because it kind of, apart from the fact that it's good to look at, it kind of also disentangles the concept in your mind, right? So you don't get into some kind of entanglement. So it kind of like this entangles the concept in your mind, like makes it like very, very where you're making a mistake. Can you guys still hear me? Can someone reply?
Yes, we can.
Okay, great, great. All right. So let's say, okay, so looking for t-shirts or jeans, then the two options, right? The answer could either be t-shirts or jeans, right? And in this kind of design now, I mean, when you also go down to UI design, and this is something that also comes in, right? So, I mean, I know we're talking about conversation design, but Esse also talked about this a little bit, right? When he talked about understanding how you also design your your bots, right? In terms of and I want to divert a little bit now. Sorry, digress a little bit to talking about platforms, right? So you need to understand where your users are. So are you designing a chatbot that you're going to integrate into WhatsApp or Telegram, or is it going to be a standalone app? Like, will your users be willing enough to, download another app on their phone just to interact with your chatbots, right? Is this going to be integrated on a web platform? Are your users on the web? So, for example, if you have a mobile app and you have a web platform, you want to like probably run some form of analytics and compare where your users actually are. Are my users on the web? Are they on the mobile platform? Are they on the web platform? You want to know where your users are. And when you discover where your users are, that's where you channel your strength. That's where you put your bots. That's where your bots should stay, because that's where users would come to. All right. Now, when you now come to the UI, for example, if this is to be a web platform, all right, or a mobile platform that is your own, I'm not talking about integrating with Telegram or Facebook or any of these guys. Now you could decide, for example, here you're saying like you're asking this user, do you want a t-shirt or a jeans? You could decide how this happens, right? So for example, if I were to do this off of the top of my head, I would just say, I would bring out what, I would design this to be two buttons, right? One saying t-shirts and the other one saying what, jeans. And then I'll allow the user to click on one. Why? Because when I say, are you looking for t-shirts or jeans? Users, like a user can, instead of typing in jeans with one S, can decide to type in jeans with two S or three S, or decide to type in jean with no S, and all those kind of mistakes, or decide to type t-shirt with no hyphen. Yes, you can actually cover for all this, all these scenarios can actually cover for it. I mean, when you write your code. But to make everything more controlled, I could just bring out two buttons. And I think it's also kind of a better user experience, right? Because they don't even have to type, just click a button. So I always get what I want to get at the end of the day at the back end. So t-shirts or jeans. So t-shirts, for example. So when we go to t-shirts, or if we go to jeans, we land at the same place. It says what size, right? So what size, and then if I mean if it's a gene, we go to 32 to 34, 34 to 36, 36 to 40. Person makes a choice. What kind of fit are you looking for? Slim fit, regular fit, skinny fit. Right? The person makes a choice, and then we'll go to any specific brand. Yes, then you add the brand name, that the person wants, and then you show the results. So let's say I want Oxford jeans, right? And you add that brand to the brand name, and then so when my bot goes to the database to make a filter in the database, it doesn't just pack out all the jeans, right, that I have entered there. It just checks for a gene that is an Oxford gene with the size of 34, that has, with size of text for that, probably a slim fit, and it presents that result to me, or all those results to me. And if it's a shirt, all right, you can see, is it small, is it medium, is it large, all right? And depending on what the user chooses, we'll go to checking if the person wants a short sleeve or a long sleeve, and then what the neck type, and then after the person makes the choice of the necktie, then the person chooses what the brand, and then same thing, the result. So you can see, right? This is what we call a decision tree, and you can already see how beneficial it is that we might want to engage in, maybe tomorrow, our next class. If we had to go through the process of trying to design a decision tree, you would realize that what it takes a lot of thought processes, right? And even if I give you this one that I have designed, like that has been designed right here, and tell you to add or remove some parts of this decision tree, it's very possible that there are details that I am missing out, right? For example, for the genes, I don't think I see anywhere where the color is being asked for, right? So you can see that's something that is missed already. What about the color of the jean? Do you want it to be blue? Do you want it to be black? Do you want it to be gray? That's not being asked for. Same thing with the polo and all that. So those are things that you could add. So it's not totally exhaustive in 1 day or 2 days to say that you would have everything, all designed into your decision tree. It's possible that as you go forward, as you look at that design again and again and again, you might want to say, oh, okay, I missed out this, or this is not necessary. I'm adding this layer, I'm not adding this layer, and all that. All right. So that aside, talking about like how decision trees help, right? It helps in creating a full picture of the problem at hand. Looking at the decision tree, you can easily understand what's missing and what needs to be modified. The second thing is that it helps us to debug faster, right? So they are like a short Bible, more like a user story, like I said before, right? A visual representation of the software requirement specification document. So as we are developing this chatbot or whatever kind of conversational AI that we are developing, when we come back to this flowchart that we've done right from the beginning, we can ask ourselves if we're in line with the actual thing that we are meant to be doing, or we are diverting, right? Are we digressing? Like, are we making a mistake somewhere? And if we are, then we can come back and make some corrections to that, and we can continue again. All right, then AI is still not at that stage that it can be trained with lots of data and perform with 100% accuracy. And that's the truth. All right. It still requires lots of hand holding by writing business logic and rules. Decision trees help wherever it becomes a little tough to ask a machine to learn and do it. Right. So when we go back to our decision tree, we can see that, oh, maybe this is a place where uh, this system might not be able to learn and do this on its own. So we actually write some form of logic to help it, to perform that particular action without necessarily allowing it to learn on like to just learn on its own. So, but without the decision tree, all those details will be modeled up. But with the details like totally shown to us like this, right? We can easily see what we need to do and not to do using a decision tree. And that's that about conversation design. All right. And I hope that's quite clear. Now, the next thing I want to talk about, and I'm not like I'm thinking I wanted to like allow a minute for questions at this stage, but um okay. Oh, there's actually a lot of questions there. Sorry, I didn't see all this. Okay. Um, I have no knowledge in programming. I hope I'm safe. Yeah. I mean, you're safe. You're safe. You're safe. Like you would understand like whatever we're doing in this class. However, yeah, if you want to like really push this, right, then you want to like delve into programming. And really, guys, I mean, I don't. There's no. I mean, programming is not really rocket science, right? And I think it's like quite understandable, especially like the way we teach it here at Coven Labs. I think programming is something that is very, very, intuitive. Yeah, it's a lot intuitive. I think one of the reasons why a lot of people don't, really get to program is because of the scare around it and not really because programming is difficult. So yeah, a few weeks of programming, if or maybe a few months of programming, you know, after you've been set out on the fundamentals can really get you a long way. Are we getting documents shared on the screen at the end of the class? Yeah, Asamata would answer that. I don't know for sure. We can't hear. Okay. Can you integrate a chatbot to LinkedIn? I've never done that actually. Yeah, I've never done that. I've never integrated a chatbot to LinkedIn, and I don't know if it's possible. However, you can check it out, or we can all check it out later. I don't. I don't know for sure. Yeah, and I've never actually had to search. That's funny. The decision tree you shared looks like a typical example of a hands-off. Is that correct? Well, yeah. I mean, hands-off is like is a design pattern. So you can design everything to be a hands-off. All right. Yeah, you can design everything to be a hands-off. Why building intent? Can you involve other stakeholders? I don't know what you mean by that. Maybe you should be more explicit. Are we going to be taught how to integrate with WhatsApp, with like WhatsApp? No, not in this class. But that information is like publicly available online. I could always drop a document to that. But why I say no is not because I would not love to, but I don't think we have enough time to even, to cover everything that we need to cover. Um, not to talk of integration, but I'll probably drop a guide or something that would help you with that. Yeah, there should be no worries around that. It's very, very easy. Okay, I'm not sure. I'm not sure. I don't know if I'll drop for WhatsApp, but I'm sure of Telegram. I'm sure of Facebook. I don't know if WhatsApp. I don't know if I'll drop for WhatsApp, but yeah, maybe. Let's see what we get to at the end of this class. All right. So when a user interacts, okay, can we just pause the questions? Yes, you can integrate the same chatbot with multiple platforms. Yes. All right. When a user interacts with a chatbot, what's his intention to use the chatbot, or what is he asking for? So this is talking about intents. And I told you guys that we're going to dealing with intents in a much deeper scope later on. So when we talk about intent, we're just talking about intention, right? Just the same way it is the same English language. What's his intention, right? So when I say I want to eat rice, right? What's the intent? Like, what is the underlying meaning of I want to eat rice? It means that I want to eat rice. Actually, I want to eat rice means I want to eat rice. But then it actually means that I'm hungry, right? I'm hungry and I want to eat rice. It depends on how you look at it. So it's a way, right? So intent talks about intention, right? So by deciphering intent, by trying to find out what the intent of every conversation is, we are trying to give our bots a way to easily understand conversations. And I said we're going to talk about something later on. Now, this is the time, right? So when you talk about why would a bot understand, why would a bot understand when I say, Alexa, switch off the light? Alexa, turn off the lights. Alexa, please switch off the lights. Can you switch off the lights? Why would Alexa understand that I'm talking about one and the same thing? Intent, right? So all those things are giving the same intent in design. So when you're designing it, they're all giving what? The same intent. All right. And this intent is what? Is turn off the light, for example. There is an intent, in that instance, there'll be an intent called turn off the light. Now, this intent can have different ways of communicating it, but it doesn't change the fact that it's the same, that the intention is the same. And what's that intention? The intention is to turn off the lights. All right. So buy cloth intent, rent movie intent, order food intent. So buy cloth intent, for example. What are the different ways you can say you can ask someone to buy you a cloth, all right? Buy me a cloth, buy a cloth for me, purchase a cloth for me, whatever, like any way you say it, right? Buy a material for me or whatever. At the end of the day, it's intent. Or if you go to a store and you say you want to say you want to buy a cloth, like you want to communicate to the board that you want to buy a cloth, right? It's the same thing. So I mean, in our decision tree flow that we just looked at, we can easily say at that point where the bot is asking the user whether you want a t-shirt or a jeans, that might be at the point where it just detected what we call the buy cloth intent. All right, because it's a cloth. Like whether it's a jean or a t-shirt, it's a cloth, right? So from there you can start narrowing it down. But at that point, it's just a cloth that he wants to buy. The rent movie intent, you can say it in different ways, but it's still renting a movie, right? Order food intent, no matter how you say it, like different ways you can talk about ordering a food, you can you can all list them as well as order food intent. So when you look at the fact that, and this is how you now know that expanding a bot, right, to be limitless, they just say limitless. Well, maybe it's actually possible, right? When you look at something like, say, if I say I want to eat, right, and I label it as, let me say I want to eat rice, right, and I label it as I want to eat intense, and then that same I want to eat, I also type it in what? In Spanish, I type it in English, I type it in Spanish, I type it in different languages, in French, in Yoruba, in Hausa, all those languages, and I give them the same intent. Anytime, anytime someone comes to that platform and uses any of those utterances that I have defined and put under that intent, what our bot is going to decipher is what? That this person actually wants to eat, right? Because anything you say in those languages that relates to what I have assigned that intent to, right? And we're going to do all this practically. We're going to assign intent. We're going to see how this works, right? It's going to fall under the I want to eat intent. So, I mean, that's how it works, right? So that's how you can make this ball cover for multiple scenarios. Now, the next thing we're going to talk about is entities. So apart from like intents, like, intent is your intention, right? But how does a bot now understand? Now, there will be a time when I'm going to clearly differentiate between natural language processing and natural language understanding. All right, there is something called natural language understanding, and it's a subset of natural language processing as an umbrella. But breaking it down will be very, very important. Okay, so someone just asked a question, guys. Okay, fine, because we don't have time. Please, when you say, "Can you buy me a cloth?" and "buy me a cloth," does it convey same meaning? The formal is a question, and the latter is not a question. So, can you buy me a cloth and buy me a cloth? Well, I think, can you buy me a cloth and buy me a cloth? Well, it depends, right? Now, in the context of when you are talking to a bot, right? We are assuming that you have the same meaning there, right? If now there are a lot of nuances that are involved with languages with humans, and we should not forget that, right? Like there are very, very big nuances, like adding just a letter, adding just a letter to a whole sentence can change the meaning of that sentence from being insultive to being, very, very polite and all that in our human communication. And that's something that is very, very funny to deal with. But we're not dealing with bots at that, granular level. We are dealing with bots at a higher level of abstraction. So if you're going to say, can you buy me a cloth, and buy me a cloth, the bot is going to assume you're talking about one and the same thing, right? Now, remember that bots are not 100% like humans. That's not the goal here. The goal here is to, use these machines as much as we can to take care of those repetitive, those mundane tasks, those tasks that, that we can easily do without necessarily having to do it ourselves, or employing someone to do it, or something like that, like browsing the internet, checking what the weather is and all that. Like, these are things that, can be done easily. So we can use bots to do that. But a bot might not understand the difference between can you buy me a cloth and buy me a cloth at that very much granular level. Although it can. Now, when I say it cannot, it all depends on design, right? But I don't think that little detail is what someone would want to bother his or herself with when it comes to design. But if it applies to your use case, that this little detail is important, then you have to include that in your conversation design for your bots, right? And when you do that, your bot will recognize when someone makes that kind of assumption, that it understands that. And I mean, your bot would handle that process clearly. But in most times, in most bots, you would see that these things are like not really handled at that very granular level, because nobody will really come and like say something like that in the recent of it. All right. Now, user bot conversations have metadata called entities that help the bot understand the scope and flow of conversation. And this is very, very important, right? Now, intention is about what we want to do, all right, what we want to say. So, like what we are trying to say, like intent, like I want to eat, right? I mean, what I'm trying to say is that I want to eat. That's what I'm trying to say, right? Um, I'm hungry. I want to eat right. That's what I'm trying to say. That makes sense. But for the bot, how does the bot understand it? So look at the example here. What the bot extracts is what? The entity. So look at the example here is I want to rent a movie. That's the example here. That's the utterance I'm making. All right. Can I rent a movie? I want to rent a movie. Rent me a movie, whatever, however you're saying it, right? Now the intent, because the bot cannot be dealing with every detail of your sentence. So we try to achieve that level of abstraction by by drawing out what the intent and the entities. So the intent is what? Rent a movie. The entity there is what? Is movie, or and what? Rent. So it can be or movie or rent, or just movie, or movie and rent. I mean, you can draw two entities from one sentence. You can draw one entity from one sentence. That's what I meant by that or and. So the entity here that I might want to take care of is what? Is the movie entity. So because when you have these entities, what you're trying to say is that, oh, like this is what you now use to instruct the bot on what to do when it extracts this kind of entity at any time from any conversation. So I want to it's like I want to why am I constantly using eating rice and I don't know. I like food, I guess. Let's just change something else. So like, let me go do with the rent a movie example I have here. So I want to rent a movie, right? So I want to rent a movie. The intent, the intent here is rent movie, right? And the entity is movie, for example, right? So any in any other way, I use that utterance to say rent me a movie, right? The intent will still be what? Rent movie, and the entity will always be movie, making it consistent, all right? Or the entity will always be what? Rent, making it consistent, and thus helping my bot to reply to that conversation consistently without making mistakes up and down. All right. Then finally, we talk about utterances, right? And utterances are like things that we've already talked about here, that I've been talking about since. Different forms that of the same question or intent and that the user may want to show. So different ways that that you can say something. I want to rent a movie. I need a movie to rent. I came to rent a movie. They all mean the same thing, right? It is suggested to have an optimum 10 utterances per intent and a minimum of 5. But this is not restricted. Yeah, it's not, but it's the standard, right? Optimally, you want to use for every intent, you want to be able to say what you want to say in the same way 10 times. So sometimes most of our time, myself and my team is spent, writing this. And I think this is one of the part of the work like I kind of enjoy the most because it gets me to think. Well, it gets me to think a lot. It gets me to, like really ask myself what I'm doing, right? Rather than just like coding thoughtlessly. It kind of brings me to that point of wanting to ask myself, how would someone who is like, a guy who is on the road, who's under the sun, who's feeling like the heat of the sun, distressed, he's angry, right? A guy in Lagos, for example, Lagos people are always angry, but a guy in Lagos, for example, how would he say this, right? And I kind of try to conceptualize it, and it's kind of like really interesting for me. And then you want to also ask yourself, a guy that's in his office, sitting down under an air conditioned, under an air conditioned environment, and is chilled. How would he want to say this, right? You need to model that too. You need to think about the woman that is not very very literate, that has her English here and there. She knows how to speak English, but everything is not complete. She picks it here and there. How would she say it, right? The man that is not very literate, how would he say it? The woman in the village, the man in the village that the son just got a phone for, how would they communicate with your chatbot? So you want to model all of that, all right? And those are like the 10 utterances. The young boy, right, whose slang is pidgin, who tries to use some friends of American English and British English and is mixing everything up together. Like, how is he going to say all these things? Like, you want to be able to model all of that to make sure that your bot covers all of these utterances and is able to draw out the right intent and the right entity from all these utterances, and thus making your bot even more efficient. That way your bot can reply consistently when this happens. All right. Now, those are the components of the chatbot at the core. Then apart from those core components are like, okay, those are not actually components of your chatbot. Sorry, I think I wrote this wrongly. Take this from me here. This is a correction. Those are like more like components of your data, right? Your data has an intent. Your data has the entities. Your data has the utterances, and of course you can call them components of a chatbot because it's the duty of the chatbot to extract them at the end of the day. But to me, I feel like they're more like components of your data actually. All right, so training the bot is another thing, right? Now, training essentially means to build a model that will learn from the existing defined intent and end for the sake of this class. Okay, wait, you can't hear me? Wow. Um, okay. Yeah, I mean, am I back? Can you hear me now? Okay. So I I actually don't know where I stopped. This is quite confusing. Okay, so let's just talk about training the bot again. I guess everyone heard me to that point. So, all right. So training essentially means to build a model that would learn from the existing set of defined. So when for you when you are starting out, all right, you want to train your bots. You want to like of course, you want to have the you want to have you ought to have defined the conversation. You ought to have predefined some intents and utterances and all that, and you want to now go ahead and train your bot on that. All right, like to start out. So training your bot on that. How do you do that, right? Um, and what does it mean? So how to do that? We are going to like be doing that practically. And but what does it mean? It means to build a model, right? It's the model that's important here. And what this model means is, so if you have like any sort of mathematical background, and you can remember from I'll use the very basic example I know to explain what this model looks like. This whole model thing looks like, and it's like this. You remember then when we were taught about linear equations in school, back in school, maybe I don't know, junior secondary school or senior secondary school or whenever. And we know that the equation of a straight line is equal to what? Y is equal to mx plus c, right? And I'm very, very sorry if you're getting lost here, but just hold on, hold on, hold on. You're safe, right? Y is equal to mx plus c. That's the equation of a straight line. And then I tell you, oh, you know what? Um, Try to fit that equation of a straight line to a set of data. Well, of course, it will not be said this way, but that's actually what it means. Now, when you see a data with the relationship, and you say that given that you see something like, say, given that 2 is 4, all right, that x is 2 when and that y is 4 when x is 2, that's where it should be. That y is 4 when x is 2, and y is 10 when x is 5, and y is 20 when x is 10. What is y when x is 40, for example? Now, basically, what's happening here is that whatever value of x is being multiplied by 2 to get y. So you see, 2 times 2 is 4, 5 times 2 is 10, and 10 times 2 is 20, and all that, right? So basically, to um to get our y when x is 40, we just need to do 2 times 40 plus 0, right? Because I mean that's all. That's the equation there. So, but because it's mx plus c, right? So the m here, which is the slope, is the 2, right? And the x here is 40, and then the c, which is the constant, which takes care of any abnormalities or any errors, is 0 in this case. So uh, equation of a straight line, mx plus c, is the general algorithm in this case, right? But the 2x plus 0, all right, or the 2x plus 1 or 2x plus 2 or whatever it is that you get, in those days when you do this thing, is what we call the model for that data. So for that particular data, the relationship between the x and the y has this model 2x plus 0, so that at any point in time, when you put a value of x into that model, the corresponding value of y that you're going to get is the correct value of y for that data, for that particular data, right? Now, that's the same thing that is happening here. So we need to build a model that when someone says, I want to eat rice, right? What should be the corresponding reply from the bots at that point, right? That's like the model here. So it should be a constant thing. It should not vary. Just like in our case where we have 2x plus 0. It should not vary that today someone comes to your bot and says, I want to eat rice, and your bot says, okay, I'm going to buy you rice. Rice is a type of food, blah blah blah. And then tomorrow someone says, comes back to your bot and says, I want to eat rice, and your bot says, I don't even know what rice is. But we need that model that is consistent, that we can always use to make predictions. And this is what actually happens with this model, right? Now, talking about, if you look at the last part of the sentence, it says on how to categorize new utterances and provide a confidence score along with it. Now, this is what happens most of the time in our bots. So in machine learning, because most of these bots engines have a machine learning system running behind it. Now, if you've attended any of our data science or machine learning classes, you'll be more comfortable here. You'll be more comfortable here. And when I use the word more, I'm very, very emphatic on more. So I'm not saying that if you've not attended it, you would not be comfortable, but you would be more comfortable if you have, right? So machine learning deals with making predictions. So to predict and say that when a user is saying this is what the user, this is the reply to that user. Let me give you a classic example of machine learning. All right. So when you go to your Gmail now and you are trying to send an email to someone and you go there and type good, for example, the next thing you would see is what? Good morning, right? Like you would see it would be a bit grayed out where the computer is trying to work. The Gmail system, sorry, not your computer. The Gmail system is trying to predict what the next thing you are trying to say, right? It's trying to say, okay, you're trying to greet someone. So since you're trying to greet someone, actually you are trying to say good morning. So can I help you complete that so that you have to type less? That is the whole idea there. So you see suggestions like good morning, good evening, and all that, right? And if of course, if it's predicting the right thing for you, you go ahead to now choose that. Now that's the same idea here. So the bot tries to make a prediction. Now it says it provides a confidence score along with it. Now I'm going to show. I mean, I just hope like we get to this point because it's more like an advanced stage in one of the tools that we're going to be using, where we get to explore the confidence score of the predictions that is coming from our bots. So let me tell you, you can use different machine learning algorithms at the same time to make different predictions. So when I say you can have a system where when someone says hello, right, all those systems at the same time try to predict what this person is trying to say and reply the user. So this like all those algorithms at the same time will try to predict what this person is trying to say so that the system can now use that to reply the user. So how does the system choose which algorithm's prediction it goes with? That's what we call the confidence score. How? So when you say hello to a system, right? Algorithm one, let's say we're combining three algorithms in this same system. Algorithm one predicts, oh, the intent here is great. He is trying to greet, all right? And predicts that with a score of 97%. Algorithm two says, no, actually, the intent here is eat. He's trying to eat. And it predicts that with a score of what? With a score of 90%. Algorithm 3 says, no, the intent here is actually sell. He's trying to sell something, right? And it predicts that with a score of what? Of 85%. Now, obviously, the one with the highest confidence score is the one with what? A confidence score of 97%, which said that what? That you are trying to actually do what? You are trying to greet. So what the system does is to select that one as the right intent and then reply based on that intent. Now, these are very, very background details of what happens behind the scene. You don't need to bother yourself with it. In fact, you basically don't even need to ever tamper with this, but I'm just trying to break this down to show you how this works. All right. So this and it's important to use these multiple algorithms sometimes because the algorithm that predicted 97% correctly now for your greeting might predict, like it might be a specialist. Let me put it that way. That algorithm might be a special, like an algorithm that is very, very good when it comes to replying greetings or things like that are related to that, but might not make the correct prediction in every other instance, right? So in the instances where it would fail, it would have a lesser confidence, and the other algorithms would have a higher confidence, and your system would always pick the one with the higher confidence, thereby making your system correct most of the time, even though some algorithms within it might be wrong. All right. So that's the logic that happens behind the scene. You don't need to bother yourself with this, but it's a cool, fun detail to know, and you can actually use it to, you know, to flex your muscles when you're having discussions with people about chatbots and make them look at you like you are a professional, like a crazy professional at when talking about chatbots and understanding this. All right, so I mean, I guess this is recorded, so you can listen to it over again if you didn't get that. It's not actually not in the slide. So the other thing is what is confidence score. So every time you try to find what intent and utterance may belong to, your model, like I said, will come up with a confidence score. This score tells you how confident your machine learning model is about recognizing the intent of the user. All right. So as confident as I mean, as your machine learning model looks at the confidence and it sees the one with a very high confidence, it uses that to reply the user. And it's if it sees at the end of the day, it's also possible that none, and that is when you have the whole thing about, please don't mark the screen, and that's when you have the whole thing about, your bot saying, oh, sorry, I don't understand what you are trying to say, can you rephrase again, or can you rephrase your statement and all that. That's what happens. All right. So what happens at that point is that the confidence score of all the algorithms within your system are very low. So let me say all of them are hitting like 30% confidence score on all their predictions, right? So that means that the bot doesn't really understand. So your system would not pick anyone at that point. You should basically tell the user that I don't understand what you're trying to say. You should rephrase yourself, or you should, or do you mean to say this other thing, right? So yeah, if it also has one with maybe, a confidence level of, let me say, maybe 50 something, which is still good, but not that good, it could easily recommend that to the user and say, oh, is this what you are trying to say in this case, right? But in the actual sense of it, it could pick nothing to be the one with the very high, like, one with a very high confidence, because it did not understand what that user is trying to say at all. Now, what kind of in what kind of cases can this come up? Of course, when the user puts in something that your system, like you've not trained your chatbot with, your chatbot does not recognize, or the person is just trying to fool around with your system, or the person misspells the words that they're trying to spell and all that. Those are the kind of cases where you would have your confidence score very low and your bot would not understand what to reply in that case. All right. So I think I'm going to dive into natural language processing in our next class. I think like we need to end the class here. I know I think we have 3 minutes to go. So I think I'll leave these 3 minutes open for questions and also for Asamata to, like, round off the class. I think we'll stop here. So we are going to dive into talking about natural language processing from our next class. And we're going to be talking like about the science of natural language processing. Very, very interesting. If you can read up an article or read up about something before the class, it would be very, very good so that we can, push ideas back and forth and talk about a lot of things. I hope you enjoyed the class. I think I can say we've come to the end of this class for today. Yeah. Asimota, over to you. Yes, can we say Siri and Google Assistants are chatbots? Yeah, they're actually chatbots. They're just advanced chatbots. They're all chatbots. You can call them contextual assistants to sound more advanced, yeah, but they're all chatbots. Yeah. Asimota.
Yeah, thank you so much, Jeff. Thank you so much. Thank you so much. So if you enjoyed the class, just tell Jeff thank you on the chat box. You can just tell him thank you. Oh, awesome, superb class. Oh,
yeah,
wow.
Thank you, guys. Yeah.
So quickly, Constance is going to drop a link to the attendance on the chat form, and you need to fill it because that's how we're going to take attendance for the class. So, Constance, please give me a minute. Okay, so Constance has put the link to the attendance on the chat box. Please fill the link. It is mandatory. Actually, it is. So fill the link and let us know. Then Funshaw will be dropping the link to a a feedback form that we also need to fill. Funsho, if you're on the call, you can just put the link up to Constance. I think you need to drop the link again on the chat box. So class commences same time tomorrow, commences around by 10 a.m. But as usual, we'll open the class up. We'll open the class up by 9:40 so that people can start coming in. Like we said before, it's actually a lot of people are in to take the class. So if you don't come on time, or if you're not online on time, somebody may just take your spot. And you can already see what happened today. We had to create an extra link on YouTube for the other guys to follow. Constance, please, you need to drop the link again. So what we can do is, if you have filled the attendance form, you can exit the call. You can exit the meeting. So the feedback form will be put on the group later so that you can fill it. But you need to fill the attendance online. So once you're done filling the attendance online, you can go off the call.